Okay, good evening, folks. Welcome to AstroQuest Online. Our leader, Kevin Kopczynski, is rebooting his computer. I guess it froze up on him. So he'll be here shortly to conduct the meeting, the program, but I'd just like to welcome everybody. We have a really interesting program in store for you tonight. It's a very important anniversary today in our manned space program. 50 years ago today, the last moonwalk took place during Apollo 17. So we're going to be talking a little bit about that mission and also show you some pictures of the constellation Taurus the Bull, which is prominent in the sky right now, and some of the interesting objects in that constellation, like the Pleiades star cluster. Caitlin Goulette's going to talk about that. And I'm also going to show some pictures of the recent passage of the moon very close to Mars. It was a really interesting event where the moon brushed by the planet Mars in the nighttime sky a few nights ago. And Kevin is back and is still muted, but there we go.
All right, so thanks, Rich. I think it sounds like Rich gave everybody a good introduction. I'm Kevin Kopczynski. I am the STEM curator here, and we're also joined by Jenny Powers, who is the director of the Science Museum, and she'll be helping out with questions in the chat. So let's go ahead and get started. What we'll do is we'll start off with Caitlin tonight and learn about Taurus, and then I'll come in with a little bit about what's going on in the night sky, and then we're going to go over to the moon and Apollo 17.
Hello, everyone. Thank you guys for joining us for another AstroQuest. And tonight I'm going to give you guys the Observer Scoop. So I do write a monthly space and astronomy newsletter called the Starry Scoop. Here's the most recent edition I have out. It's just double-sided. If you guys would like to receive copies of your own, you can reach me at starryscoop@gmail.com or go on my Facebook, which is just Starry Scoop. So tonight we'll be exploring the constellation Taurus the Bull. But before I get into that, let me explain to you what a constellation is. There are 80 official constellations in our sky, and like I always say, think of them as puzzle pieces. They each take up their specific area and region and all fit together perfectly to create the entire celestial sphere. Now, to the right here, we have a star map of Taurus, and this highlighted region is its official constellation, and you can really see its borders right here. And we recognize these constellations with their bright stars creating recognizable star patterns. So on this map, each black dot represents a star, and the bigger the dot, the brighter the star is in the sky. And we can see how some of these stars are connected with some lines, and this is the star pattern of Taurus and how we recognize it. We have its V-shaped head, horn, and body out there. To the left here, we have what Taurus appears as with the unaided eye. We have its V-shaped head, horn, and body. And you might have to use your imagination to see this. So these official constellations were only created about 100 years ago when a group of astronomers got together and decided to create them. Before that, astronomers used these cartoon drawings of constellations. And these aren't too accurate. They were more focused on the lore or backstory of these constellations. And here are a few examples of Taurus. So tonight we'll be going over a few objects within the Taurus constellation. To the map on the right, I just highlighted all the objects in and around it that just piqued astronomers' interest. We'll be discussing, in Taurus, there are some double stars that you can observe. Double stars are stars that to the unaided eye appear as a single point of light, but with binoculars or a telescope, multiple stars can be revealed. Tonight, we'll also be discussing some star clusters. In particular, we'll be discussing galactic star clusters, which are very loose groupings of young stars that are siblings. They're all born from the same gas cloud, and they're loosely held together by gravity, and over time, they're going to flow apart. And some of them are just gorgeous. We'll also be discussing a lot of nebulae. Nebulae are just gas and dust clouds in space. And of course, Mars. Now, where are the galaxies within this region of the sky? When we look at the Taurus region, we're looking at the space that's directly opposite of the core of our galaxy. We're looking at the anti-center. Now, when we're looking at this, we're looking at our galaxy edge on. And even though it's the anti-center, it's so compact of all the stuff in our galaxy that we can't see the other galaxies behind our own. So we see very minimal galaxies within this region of the sky. So the first object we'll be discussing tonight is the Pleiades star cluster, also known as the Seven Sisters. This is probably one of the most famous star clusters in our sky. It's been known for thousands of years. It's appeared, I know, in the Bible a few times and in Homer's Odyssey and Iliad. So in the star map, it's on the bull's back. It's very easily recognizable with your unaided eye. I think you can see up to 12 stars, but 6 or 7 is the most common or the most easiest. And with a simple pair of binoculars, dozens more stars can be revealed. They're made of young blue stars. And again, they're open star clusters or galactic star clusters. So they're very loosely held together by gravity. And over time, their stellar winds will push them apart and they'll just kind of disperse. We have another galactic star cluster, the Hyades. They mark the bull's face. So they're a V-shaped. You can kind of see in this star map and in this photo. And a great way to pick out this star cluster is using the star Aldebaran. It shines a bright orange red and it's just beautiful. It marks the bull's red eye. Now, Aldebaran is not part of this star cluster. It's just a line of sight coincidence, like 2 ships passing at sea, one close and another far. We also have the Crab Nebula, supernova remnant. This is probably one of my favorite objects, not only because it's fun to observe, but because of its history. A few thousand years ago in 1054, Chinese astronomers saw a guest star in the sky, and it shone brighter than any other star-like object, appeared in the daytime sky for 23 days, and was in the nighttime sky for 2 years. Eventually, it faded from view. But today, when we point our telescopes at where this object is, we'll see the Crab Nebula. And this is a photo by NASA. And in the center is a neutron star, one of the densest objects in the universe. And finally, we have Mars. This is probably one of my favorite planets. The ecliptic runs through Taurus. This is the apparent path of the sun. And this makes Taurus a zodiac constellation. So it's probably one of the more famous ones.
Caitlin, can I just jump in and ask you a question? When you say, when you used the word ecliptic in a sentence, can you repeat that sentence and can you define that word for us?
Yeah, the ecliptic runs through the Taurus constellation, and the ecliptic is the apparent path of the sun. So when the sun's in our sky, this is where it travels. So Mars is in Taurus for the time being, and it actually just reached opposition on the 8th. So that means that it reached its closest distance to us, and it was at its brightest. So these next few weeks will be the prime time to observe Mars. And with a simple backyard telescope, you'll be able to resolve details, the polar ice caps. And this is a photo taken by NASA's Hubble telescope. And this is actually when a lot of dust storms are on it. But without them, I think it's pretty clear now. You'll be able to see a ton of detail. So good luck and happy observing. Thank you all for watching.
Thank you, Caitlin. And yeah, I'd like to go to the just a very quick thing on the night sky. However, I think Jenny raised a very good question that I think I would like to address in a little more detail. There's Stellarium. Stellarium is this program that you can get for any computer. and it shows you how things look in the night sky. Let's take a look at the day sky for a moment. So let's see, what is this? The west. So let's go, and I love doing things like this. It's great working in planetariums or whatever. You can be just in charge of time. So we're going to go back into the afternoon. What is that, about 1 o'clock in the afternoon? There's the sun. Notice how low the sun is, and it's 1 o'clock in the afternoon. Look at how low the sun is to the horizon. And then we shall pretend that we can see through the atmosphere in the day and look at the sun here. When we talk about the path of the sun through the sky, this is probably my big breakthrough in understanding the sky and planets and so on, is that it's not referring to, oh, the sun rises in the east and sets in the west every day. We're talking about looking at the sun from day to day and thinking about where it is in relation to the stars, as if we could see through the atmosphere and see the sun out there. Notice how nearby Mercury and Venus are right now. And if we go ahead and move a few days, notice the two stars right under the sun, okay? And notice now that the sun has moved in relation to those stars. And again, as we've stepped through a few days, that we're on spaceship Earth. We're traveling around the sun. And as we travel around the sun, just like being in a vehicle, a car or whatever, and you're traveling along, you look out and the things that are close to you seem to be going by pretty fast. The things that are further away are going by slowly, and things that are really far away may hardly seem to move at all. Well, from our perspective on spaceship Earth, the stars are so far away that they just don't look like they move. The sun, however, is much, much closer than them. And so as we're traveling, it does look like the sun is traveling against the background of the stars. And that's the kind of motion that people have known about for millennia, and that help them to observe the sky. So if we were to trace, if the sun could leave a mark behind itself, right, or whatever, it would trace out a path across the stars and there's the ecliptic. And sure enough, look at Mercury and Venus right there, right near. Mercury is actually pretty far. It's the furthest planet off of the ecliptic. So that's the idea of the sun's motion through the sky, that day by day. And let's come back to tonight. So let's reverse that motion. Day by day, it just looks like it's sliding out there and moving against the background of the stars very slowly. You know, it's really hard to notice from day to day, but after a week or so, the sun's going to be against different stars. Different stars will be coming up at sunset, or will be visible at sunset than a week before. Okay, so let's go back now to the evening. So there, look at there's Saturn, right against the ecliptic. Notice that the Mercury and Venus were so close to the sun that we don't get to see them by the time it's dark. Now, that'll change. Okay, so, and then if we swing around, there's the ecliptic line and there's Mars. Again, that is, again, it was certainly sort of a breakthrough for me, understanding, you know, that's what we're talking about with the motion of the sun and look at Jupiter right there, hanging right by the ecliptic, pretty much. Okay, so, and people knew this. People, again, for literally millennia, thousands of years, people have known this. And this is one reason why the zodiac constellations became so noted, because each one of these is near a zodiac constellation. Right now, Saturn's over near Capricorn. Jupiter, I believe it's Aquarius, it might be Pisces. And Mars, as we have learned from Caitlin, is right going through Taurus, right through the edge of Taurus right there. So and that's what I did certainly want to point out, that, hey, you can get out there and see some planets. Mars just had its opposition. In other words, it was opposite. If the sun, Mars, us, and the sun were in a straight line, it was directly opposite us. Opposite the sun from us. And also it is at a close point in its orbit to us. So it looks larger in a telescope than it will next year, than it will even in a few months. And so a great time. But even, without a telescope, you can notice its reddish color. And you can compare it to Aldebaran, which has a slight orangey color as well. So the other, as I mentioned before, we don't get to see Venus and Mercury yet. We will start to see them towards the end of the month. We're going to go to the 24th, but we will have to, this is going to be sort of a race. There we go. Let's get them front and center there. So we're talking about 7:18. That's going to be about an hour after sunset. Sunset would be maybe about 4:28 or maybe 4:30, so maybe it's 50 minutes. It's going to be a crescent moon, very slim crescent moon. Mercury is making an appearance into the evening sky, and we also now Venus will be starting its appearance into the evening sky, which will continue through the new year, well into the new year. But you can possibly see those. You're going to need a really good, clear western horizon or a high vantage point, something like that, to be able to see that. But let you all know about that just in case you have that opportunity. Another thing to think about also tonight and somewhat tomorrow night are nights for the Geminid meteor shower. The Geminids are a meteor shower. They're a different sort of meteor shower. A meteor shower happens when something that has been orbiting through the solar system, usually a comet, leaves stuff behind, and then we orbit through it. It hits our atmosphere, and all those little particles hit, and we get what we call shooting stars or meteors. The object that gives us the Geminids is a little different. That object is actually a asteroid, and its particles are traveling more slowly. The particles tend to be more dense, so the meteors from this particular shower tend to be slower, last longer in the sky, and possibly are somewhat brighter. So I went ahead to 8 o'clock. There is Gemini. So here's the easily recognizable Orion. Right. And so if you're going to look somewhat to the left and maybe somewhat above Orion, you will see two stars that looking very similar to each other. And that's where Gemini is. But now they're called the Geminids because they appear to come from this direction, but they don't come from Gemini. It's just that we happen to be facing Gemini as we plow into all those particles. And if you did look right, if you're looking right at this source, it's called the radiant, then the meteors are going to be coming like right at you. And that means basically what you would see, if you could even notice it, you would just see a dot that kind of gets bigger and then winks out, which is going to be hard to notice. What you want to be looking somewhat to the side. It doesn't matter which side. And so if they come from there, and if you see them in this part of the sky, you'll actually see them make a streak. And then if you can, in your mind's eye quickly, you can trace that streak back to Gemini. So that the peak is, this is an interesting situation for the Geminis. The peak is actually tomorrow morning. So we're about 12 hours before the peak tonight in the early evening. And we're going to be about 12 hours after the peak, actually less, no, about 12 hours after the peak in the early evening tomorrow. So they're both nights, tonight may be slightly better, but both nights could be good times to try that. All right, so there is there's our look at the night sky. So thanks. Jenny, any comments or questions we should think about in the chat?
Nothing in the chat so far, Kevin, but thank you for
Okay.
that very illuminating explanation on that.
Okay, yeah, like I said, that to me was just a breakthrough in understanding how people talk about the sky, how people look at the sky, and so on. You've heard from Rich already. Thank you, Rich, for filling in on extremely short notice.
We have not heard from Rich.
Well, I mean, you heard from him. He was sort of introducing and hosting and right while
I was just babbling for a few minutes.
there you go, babbling for a few minutes, whatever.
I'm good at that.
So Rich is the president of our local astronomy club, the STARS. That is an acronym, Springfield Telescope and Reflector Society, and Caitlin is a longtime member, actually, of that group.
Yeah, Caitlin's actually a member of the board of directors.
And that's right, yeah. So, and we at the museum, we are privileged to have the assistance of people from the STARS Club in our events. So, Rich, how about we'll go ahead. I think your pictures are ready to go. So we can go ahead and get started. Yeah, there we go. We're set.
Great. Okay. Well, good evening, folks. I'd like to talk about an event that happened a week ago that was kind of exciting in the nighttime sky. And, you know, stargazers love alignments of celestial objects. An eclipse of the sun or the moon is basically an alignment of the sun, earth, and moon. But a week ago, on December 7th, another interesting alignment took place where Mars, planet Mars, the moon, and the earth were lined up. And what happened, for a large part of the United States, the moon actually covered up Mars. The full moon covered Mars, and Mars disappeared from the sky while it was behind the moon and then reappeared on the other side. But for other parts of the country, the moon came close to Mars, but didn't cover it. But from the Springfield, Massachusetts area in Western Mass, Mars came very, very close to the moon. The moon grazed right by Mars, and that in some ways is even more spectacular than covering it, to see Mars and the moon so close together. And it's an event called a pulse, A-P-P-U-L-S-E. A pulse is basically a fancy word for two celestial objects coming close together in the night sky. And that's what happened. And I'll go through quickly a sequence of pictures. I took these using a handheld iPhone to the eyepiece of my 8-inch Dobsonian telescope that I made back in the 80s for Halley's Comet and still use. And as you can see, it delivers a pretty nice crisp image. And that night was pretty steady as far as the atmosphere is concerned. And so I was able to get some pretty nice pictures of this relatively rare event. Now, the reason I put Feeding Hills in the title up above is because your location will determine the type of pictures, how they appear, because people from other parts of the country, as I said, saw the moon cover Mars. Other people saw Mars stay further away from the moon. So your location is very critical for an event like this. So this is these are pictures from Feeding Hills, where I live, from my backyard, of the appulse of the moon and Mars. And that's Mars on the left, that bright dot. As the moon was approaching it, it was supposed to be 89% cloudy that night, according to the forecast, but it turned out to be about 90% clear, which was nice. And next picture, there was a little bit of ground fog for a while, and some clouds came over. There were times where I had to wait for a cloud to pass over the moon and Mars, but there were enough large gaps between the clouds that I was able to get a pretty good sequence of the entire event. You can see on the moon the beautiful crater Tycho on the lower left, at the southern highlands of the moon, with all the rays extending from it like the spokes of a bicycle wheel, a new crater. It was such a violent impact that it shot debris all around the moon and created those rays that are very prominent during a full moon. And so it was a full moon that night, and Mars was at its closest, just about, so Mars was bright. And you can see how tiny Mars is. It really gives you an appreciation for the folks that get these detailed photographs of Mars, because look, it's just like a little dot next to the moon. It's really a small planet, and it's very far away compared to the moon. Next one. Now, this was the exciting time when Mars almost grazed the moon. It was almost like grazing the mountain peaks along the limb of the moon that you can see in the bottom left. And there's a close-up of Tycho, the crater above it, and there's Mars right below the limb of the moon. Now, what's interesting is not only the contrast of color. The moon is sort of like plaster of Paris. The moon is actually like slate. It's very dark, but it looks bright in these pictures. Mars is a ruddy red color. Now, what's interesting is there's a value that you can give a celestial object called albedo. There's another fancy word, albedo. And what that basically means is how much light that hits the object is reflected. So the moon's albedo is 0.12. And all that means is that the sunlight that hits the moon, 12% of it is reflected during the full moon, 12%. So about 1/10 of the light that hits the moon is reflected back to us. But Mars reflects 16% of the light that hits it. So why is the moon brighter than Mars? Well, there's a good answer to that, and that's because Mars is further away, much further from the sun and the Earth. It's in a darker part of space because it's further from the sun. And when you shine a flashlight, the longer that light goes, or the light from a star, the dimmer it becomes. And so the sunlight that hits Mars is much dimmer than the sunlight that hits the moon. And then the light has to come all the way back from Mars to us. So the moon in this picture is 250,000 miles away, and Mars is 200 times further than that, 50 million miles. So that's why Mars is dimmer than the moon, and when it's really brighter, it really reflects more light. It has to do with the distance. So it was just so beautiful to see the Mars grazed by the moon. It reminded me of those Earthrise pictures that you see from lunar orbit of the Earth rising above the lunar landscape, only in this case, it's Mars as seen from afar. There's Mars in the lower right after it made its closest approach, and now the moon is moving away. And what you're seeing is the moon's orbital motion. The moon is moving past Mars. Mars is orbiting the sun much slower, but the moon is moving relatively quickly past Mars. So I was outdoors photographing for about 3 hours and saw this. And I said it's a fairly rare event. There's going to be another close approach at the end of January, but nowhere near as close as this one. And then the next time that the moon's going to cover Mars will be in a few years. So it's like an eclipse. It's relatively rare, but not exceedingly rare. Now, here's a few pictures that I took actually, I think 3 nights ago of the moon. And as I've said in previous programs, we often look at the line along the moon called the terminator, where the sun is either rising or setting. Now, I took this picture after the full moon. It was after that night when Mars went close to the full moon, a few nights later. And so the full moon was shrinking in size as it orbits around the Earth. And so what you would see along that line between the light and the dark area is sunset from the lunar surface. And the sunset casts shadows just like it does on Earth when it's low, and it brings out enormous detail in the moon's features. And that's why we love to look at the moon at this time. Look at all the detail along the limb of the moon. Next slide. And this kind of explains it. This is a picture I took during a hike in Robinson State Park. And it's, the bark of a pine tree with the sun hitting it from the right, just like the sun was hitting the moon along that terminator. And it just shows how the low angle of the sun brings out a lot of detail in the bark of a tree, as well as in the mountains and craters of the moon. Next. Okay, so here's that same night, that same picture, a low power version of it, as well as the zoomed in version with a higher powered eyepiece, again, using a handheld iPhone and my 8-inch reflecting telescope. It's an eyepiece that delivers about 100 power for the picture on the right, and the picture on the left about 50 power to get the entire moon. And I've highlighted the upper right quadrant because that's an interesting part geologically, an interesting quadrant on the moon when the sun is setting or rising in that region. And on the right, some of the features are labeled the Sea of Crises, the Sea of Fertility, the Sea of Tranquility. And this harkens back to a time hundreds of years ago when stargazers looked at the moon with the naked eye before there were telescopes, and they could see these blotches very indistinctly because they weren't magnifying the moon, and they assumed that they were bodies of water. And it's a logical assumption. The Earth has bodies of water. There's another world in space with these dark blotches. Those must be oceans and seas. So they named them that way. And those names have stuck. And that's why we have Sea of Tranquility, which was the landing site of Apollo 11, which is shown toward the bottom left of the picture there. Remember Tranquility Base here, the Eagle has landed. That was Apollo 11 in the summer of 1969. In the upper part of the picture, you see the landing site of Apollo 17. So there's the first and the last lunar landings in which astronauts walked on the moon. And you see how the first landing was in a relatively flat area, and that dark area is lava plains where it's relatively flat and uncratered and less dangerous. But by 17, they went to a geologically interesting area, which was a little more hazardous, but provided a lot more interesting science in that rugged area in the upper part where it's labeled. So Apollo 17, as I said, was the final of the missions to the moon. There were supposed to be several others, but there was a lack of interest after Apollo 11, which was arguably one of the greatest events in human history, but there was sort of a loss of interest, and they canceled the last few missions, and it turned out Apollo 17 was the last one. And as I said at the opening, while Kevin was rebooting his computer, I mentioned how today is the 50th anniversary of the final stroll along the moon's surface by human beings, 50 years ago today. And we all remember Neil Armstrong's one small step for man, one giant leap for mankind. Should have been humankind, but it was the 60s back then. And so that was the first landing. 17 was the final one, and that represents the last time that people have been to the lunar surface. There were 3 astronauts. Gene Cernan was the commander. Harrison Schmitt was the lunar module pilot, and he was the last person to step onto the moon. Cernan went onto the moon first, then Harrison Schmitt stepped onto the moon. The last person to step onto the moon was the first scientist to step on the moon. He was a geologist. And because of an outcry from the scientific community, they bumped another astronaut and inserted Harrison Schmitt, so they get at least one scientist to the moon, which I think was a good thing.
Rich, I have a question for you in the chat.
Oh, sure. Okay.
So I think it could be interpreted 2 different ways. What is the Well, I interpreted it two different ways, perhaps wrongly, but what is the distance between the Apollo 11 and the Apollo 17 landings? So I think that Marguerite means on geography wise, but then I was also wondering if you know the time difference between when Apollo 11 landed and Apollo 17 landed.
Well, Apollo 11 was July of 1969 and Apollo 17 was December of 1972. There was a delay of about a year after the Apollo 13 near disaster when it blew up and they didn't land on the moon, but safely made it back to Earth. So the last mission was at the very end of 1972. At the distance, I would guess maybe 400 or 500 miles. I'm not really sure, 400 miles maybe. But anyways, I wanted to read a passage. And as I said, you know, Neil Armstrong stepped into history when he made the first boot print on the lunar surface, which he accidentally obliterated before he got a photograph of it. But he made the first footprint on the lunar surface and everybody was glued to the TV. More people saw that than anything before that in history on TV. It was such an amazing event. And it was a life-changing event for me as I was glued to the TV for all the Gemini and Apollo missions during my teen years. But few people remember the last footstep on the moon. Now Gene Cernan and Harrison Schmitt have argued about who was the last person on the moon because Harrison stepped onto the moon last, but Gene Cernan left the moon last. Harrison got back into the lunar module, and Gene Cernan was the last human being to be standing on the surface of the moon 50 years ago today. And what I'd like to do is, a friend of mine named Andrew Chaikin wrote an amazing book called A Man on the Moon. And I met Andrew Chaikin decades ago and we, you know, became a friend of his. And we actually had him speak at the Science Museum back in 2001 when we had the Hubble telescope traveling exhibit. He was the featured speaker for that exhibit. But years before that, 1993, he wrote A Man on the Moon, which was a history of the lunar landings, Apollo landings. And I would say it's the best space-related book, space exploration-related book I've ever read. It's just an exceptional, exceptional book, and I encourage everybody to read it. It was written in 1993. It's still available. By the time we had the Hubble exhibit, he came and spoke, and then shortly after that, a mini series From the Earth to the Moon was on TV, a multi-part series with Tom Hanks based on the book, which he became so famous after that, I don't think we could have gotten. But what I would like to do is read from Andy Chaikin's Facebook page. He's one of my Facebook buddies, and he posted today about this anniversary. And there's been these 50th anniversaries going on since Apollo 11. We've been reaching these anniversaries, and this is the last one for Apollo 17 happening right now. And let me read what he wrote. This will take a few minutes, but I think it's very profound. And as I said, this had such an important, profound effect on my life, these missions to the moon, that I'll try not to get emotional as I read this. Okay, these are Andy's words, but he quotes a lot from Gene Cernan from the recording. Okay, Andy wrote today on Facebook, 50 years ago tonight, Apollo 17 Commander Gene Cernan took the last human footsteps on the moon of the 20th century. As we await the return to the moon with the NASA Artemis missions, I offer this passage from my book, A Man on the Moon. And then he quotes his book. After loading the rock boxes and other cargo into the LEM, he had to climb the ladder several times to pass the massive storage bags to Schmitt. Gene Cernan stood alone on the moon, his space suit covered with grime. He was somewhat out of breath, and now he spoke. So here's Gene Cernan, the last man on the moon, about to step back into the spacecraft, knowing that nobody's going to step on the moon for a long time. And he was tired but emotional. Trying to cut through the fatigue, Andy Chaikin writes, to imbue his words with energy, to speak for the history books. And then he quotes Gene Cernan. Bob, this is Gene, as I take the last steps from the surface back home for some time to come, but we believe not too long into the future. Then he pauses. His words were interrupted by the sound of his own breathing. I believe history will record that America's challenge of today has forged our destiny of tomorrow. As he spoke, Cernan took a last look at the bright and barren wilderness all around him. And he said, as we leave the moon at Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Humankind. I'm going to change history and say humankind. He glanced at the earth high in the southwestern sky, an unmoving, silent witness to a voyager about to begin a long journey back home. Once more he spoke, Godspeed, the crew of Apollo 17. And then he stepped onto the lunar module, blasted into lunar orbit, came back to Earth, and no human being has walked on the moon since then, 50 years ago today. But it won't be another 50 years, I don't think. We're going to see people returning to the moon, barring some tragic accident or something like that. If things go as planned, the Artemis mission just went to the moon and came back successfully and sent back some beautiful pictures. That was just a robotic mission, but the next mission will have astronauts on board and correct some errors that were made in the olden days. People weren't quite as enlightened as they are today, with some female astronauts, some people of color, different types of folks to represent the population of planet Earth instead of the population of test pilots, test pilot jockeys from the 1950s and 60s, which are the ones who made up the astronaut corps back then. So we have some exciting times ahead, and hopefully children today will, in the years to come, be inspired the way I was back in the 1960s and early 70s by these dramatic milestones in outer space. Back to you, Kevin.
Okay, Rich, thank you very much. I'm going to keep this screen up for a moment. Yeah, I think the estimate of 400 or 500 miles is probably really good. I'm thinking, the little square here that covers the landing site that we're going to look at in a few minutes, that landing site was about 10 miles across, and that's kind of covered up in there. So that, definitely we're looking at hundreds of miles apart. I'm going to just continue the pictures on here for just a couple of three of them. Pictures from that mission. Remember this picture with the flag sort of, and the flag in front of the lander and sort of off in the distance there when we take a look at something else a little later. You can, a lot of the Apollo pictures are on Flickr. NASA has posted a lot of them on Flickr. That's where I pulled these down. And one of the things they did was sample a boulder. I'm going to show you why they were interested in this boulder in a moment, but we can see it there. He's working on it, doing something over there, getting a sampler or something. And then one of the probably more interesting parts of the trip, and probably a good example of why it's good to have people up there. Look, you can see this soil, right? That it has this sort of orange color. Schmidt caught this out of the corner of his eye, and sort of went to have a closer look. This turned out to be pretty interesting because the orange turned out to be the raining down of volcanic beads. So there was a volcanic explosion that put the lava up into the sky. all the little drops solidified basically into glass, settled down, got covered, except something smashed in and uncovered it. So that he noticed it, and so there was some direct evidence of volcanic activity up there on the moon. Okay, so we're gonna shift gears here and finish up and see if we can take our own trip out there. We shall be looking at the program Open Space, and they have set up some highlights from that mission. All right, so there we are. We're hovering over the moon. The area that they landed in is getting circled there by the mouse, right about in that area. Actually, you might see something kind of different there. That's some of the features that Open Space has put in. So as Rich mentioned, these areas, the dark areas, are lava flows, basically. Whatever happened in these areas was covered over by lava that flowed up and out. Basically, look at these are massive circles. These were massive strikes early in the history of the moon, when it was still molten inside. The lava welled up and just covered everything. And so it's a younger surface. The other areas that are more pockmarked with craters and higher, those are older surfaces. And as Rich mentioned, the earlier missions, they were going to sort of nice, safe, flat areas. Well, it turns out this particular area they went to is not all that dangerous, but still, it did give the opportunity. So let's move in a little bit. It did give the opportunity to sample some more of this type of area, some of this more older type of material. And so we're seeing Open Space brings together data and images from different satellites. So we have a couple of insets there from different satellites, higher power cameras, and so on. So let's go in to this area. This area is the Taurus Littoral Valley. The mare Serenitatis is up above to our left. So this is an inset that was created with a higher resolution image and overlaid with some information about the mission. All right, and we're going to need to let that kind of come into focus. I think this is reloading after the crash. One thing, as we look from the distance here, so we have the valley down here, huge mountains to either side. These mountains are like 6,000 feet tall. And notice that on this edge, that there was some kind of a landslide, that the upper material, the lighter upper material, the older material flowed down for some reason into this area. See how it kind of spills in and covers the low flat area, which was covered in by lava. So that made a really good place for them to try to go sample. And you can see this yellow line represents, this is the second day of excursion with the lunar with the buggy, the cart, and they followed this route. They went out there, they did some sampling, they came back here. This crater called Shorty, this is where they found the orange soil. Right, and then on the third day, they went over and they sampled over here. And one of the things that they sampled was a boulder. What happened here, if we can come down and have a look and get a little closer, what happened here is that this boulder rolled downhill from further up. Got dislodged by some event, some other probably vibrations from some subsequent strike, and ended up rolling down the hill where they could get at it. So again, they had this idea of sampling this stuff that's up from higher and was older, and they were able to get some of it from there. So let's go. All right, so that's sort of the overview. And again, this is the area. This area is about 10 miles across from the north to the south mountains, about 10 miles across. And again, those mountains are somewhere around 6,000 feet high. Well, we also have a real close-up. This is with the close-up camera on the Lunar Reconnaissance Orbiter. That thing, each pixel on that is like 25 centimeters on the surface. It's amazing, amazing detail. I'm going to lose that larger map and let us really focus in on this. So from orbit, they can barely see, something there that got left, that the bottom part, not too clearly, but see all those tracks there? Those are all astronaut tracks. Coming in a little more, see this track right here that kind of comes up and stops? They did some photography from here. See and there's the position of the flag, right? They did some photography from here, and I'm thinking that perhaps this is the place where they took the first picture that I showed you, where it would come back. You'd have the flag, you'd have the lunar module, all in the same image. So, and then, from where the word said flag and following down, those double tracks, that's from the rover. That's from the lunar rover. Here is the final parking place of the lunar rover. And what they did is they had cameras on that were recording the blast off of the module back up into space. And and NASA has that video. I think I saw some of that somewhere as well. It's quite a sort of opportunity here to look at, look at this in more detail. Well, actually, let's get in down there, because what the folks at Open Space did is they got a picture, or they took pictures of one of the lunar lander models, and they superimposed it into this scene. All right, so this is, so this is a full mock-up of the lander. This is superimposed. This is a 3D model, and because there's not still an astronaut there. Okay, so this part is superimposed on that dark spot. That's like the the couple of dozen pixels that mark the site where the actual bottom part still rests. But they created this view from down here, so we can kind of come in and start looking around and kind of get a view that maybe they had as well. And we'll finish off with that tonight. For those of us who like straight horizons, we'll take care of that. And then see if so again, those mountains, those mountains are like 4 or 5 miles away. And that's the special inset of where they sampled the boulder. That wouldn't have looked like that. But I don't know about the lighting or the colors, but the size of those things is something that they would have seen. And then let's see if I remember right. If we look up from right about here, there it is. Okay, the crescent Earth. And there's some kind of a glitch that I spent most of the day trying to solve, where that orange line should not be there. That's some kind of an artifact. And so they would have been working with sort of a crescent Earth, sort of looking down on them as they looked up into the sky and looked around in this environment. So we were treated to Cernan's words as he left this, and well, we can kind of end up tonight just having a look at what they saw. Okay, so I think that's pretty much going to wrap us up. Jenny, do you got anything else in the chat or anything?
Hey, Kevin, a lot of people talking about being excited about astronomy, but no questions right now.
Okay, well, that's the best thing. That's the best thing. Glad everybody's very excited about that, and it's fun to see stuff like this. It does add a lot of interest to the study.
Evan,
Okay.
is that open space on an app, or is it just a website that you go on?
It is, I guess, in the modern word, an app, but it's not really an app. It is a very powerful program application. It could be the fact that I had this running and a bunch of other stuff is what crashed out my computer. I'm not sure. But it's a very powerful program. It is free. It's about a 5 gigabyte download. It's free. Unlike Stellarium, it's not going to run on any computer. You need a pretty good gaming class computer probably to run this with a great graphics card that does 3D. You know, look at it. That's like 3D rendering right there. You know, and again, granted, people aren't running around and doing stuff in this, but what this program is doing, you know, as we pan around, it is accessing, it's going from, remember, you know, they didn't do movies, right? This is all still images. And this program is seamlessly, for the most part, stitching together the still images. It's combining the visual data with radar data, laser data, actually, to give the heights of the objects. So that we can, so it's combining the visual data and the height data to give us this really illusion of looking at mountains from the surface of the moon. So it is very powerful. But if you do have the computer that runs it, oh boy, it's free. It is technically beta, so I'm not surprised maybe it crashed. Okay, and so folks, thanks so much for coming by tonight. We're going to sort of leave us off here with our view. Maybe we'll just straighten out the view of the moon, but we'll leave off with the view of the moon. Thanks so much for coming by. Stars Club meeting is next Tuesday. Stars over Springfield, first Friday of January, and the next installment of AstroQuest will be the second Tuesday of January. So hope to see everybody at all or one of those things. Have a great new year and happy holidays to everybody, and thanks so much for attending today.